Good morning, students and dear colleagues. The questions that why light get deviated from its actual path while passing from one medium to another medium has been remained unanswered, or there is a lack of authentic answer to these questions. So many times I have been asked by principals and even scholars of physics that why light get deviated or bent when making a transition from one optical media to another one. And traditional answer that we people know is that because the speed of light get changed, that's why it get bent. But this is not satisfactory answer. This might be answered for the students to standard 8 or standard 6, 7. But even in that standard, if a student asks that why speed gets changed, still then it becomes a typical to think that it is not appropriate answer. Therefore, we physicists or a scholar of physics, we people must give authentic answer that may not be questioned once more. So think that why light get bent. If your answer is that because it is speed change, then again question rises, why speed gets changed? Then someone says that because its wavelength gets changed. Even then question arises, why wavelength gets changed? So this is not the authentic way to answer. At least for people, we teach the student. That is for teachers. At least teachers must know the authentic answer to these questions. Don't go to the traditional way, because uh, we teacher shape the new generation. Whatever we give the knowledge to new generation, this knowledge will prevail to distant or to remote. So knowledge given by teachers to students must be authentic and satisfactory. So let us start with the uh, query that why light get bent while moving from one medium to another medium. First of all, let me take a brief discussion about the spectrum of light. Then we will focus over the main question that why light get bent while passing from one medium to another medium. So as we know that a spectrum of light extends far beyond the visible light that our eyes evolved to detect. Light itself is an electromagnetic wave. So a range of this wave is not up to the visible light. It is beyond that one. Like cell phones and Wi-Fi use microwaves light, or simply microwaves, which is a part of electromagnetic spectrum or electromagnetic wave. And Wi-Fi and cell phone use microwave to transmit digital information. Similarly, CT scans use X-ray light to look inside a person's body. Although these X-ray or microwave are not visible to our our eye has a limitation that it can detect only visible component of electromagnetic wave. Similarly, thermometer use infrared light or radiations of electromagnetic wave, to read temperature. So all of these different types of light or simply wave are produced in the same way. And that's why these all kinds of wave, or you can say even light, are electromagnetic wave because they are produced in the same way. So let us talk about what is the way to produce all these waves. In the laboratory, it has been performed various kinds of experiment to view various component of radiation that is contained in radiation of sun. So first of all, let us check out. Many scientists concluded that the sun radiates the energy in the form of electromagnetic wave, including visible light. And all these radiations are nothing but electromagnetic wave. This implies that this radiation consists of periodical variation of electric and magnetic field, which is perpendicular to the direction of propagation of the wave. So check out how these waves are produced in the same way with the same method. So let us check out. When a charged particle, we have already studied and we know well that a charged particle produces a vector field around it called electric field, which depends on magnitude of charge contained in a body or a source charge body, and is independent of mechanical states of charge body. Whether charge body is at rest or in uniform motion, the vector field called electric field will be there, and this vector field will be spherically symmetrical as if the charge body is at the center of a sphere, and this field will extend to infinity and will propagate in the space with the speed of light. So when a charged particle is at rest, it produces electric field only around it, and when charged particle moves with uniform velocity, then it produces an additional vector field called magnetic field. So magnetic field is a velocity dependent field. So as long as velocity is there, magnetic field will be associated with the moving charge body. On the other hand, electric field is independent of velocity. So it is a velocity independent field, whether there is velocity or not. Electric field will be there present all around the source charge body. So it's electric field and magnetic field associated with the accelerating charge body. Now come to the point we have to discuss about what about a charge body which keeps on accelerating. Will then electric field and magnetic field remain uniform or constant? This is the questions to answer. Of course, as long as charge body is moving uniformly, it will have two kinds of vector field associated with the moving charge body. One is electric field and other is magnetic field. Although electric field is velocity independent field, on the other hand, magnetic field is a velocity dependent field. Now question is that, now when charge particle starts accelerating, will then electric field remain independent? Will then magnetic field remain uniform? Answer is not at all. Because of acceleration, electric field will change. Because with respect to an observer, particle is accelerating. Therefore, according to theory of relativity, accelerating charge body will radiate energy in the form of electromagnetic wave. So how it is so? So when charge body accelerates, then electric field and magnetic field associated with the accelerating charge body will change. And the change in electric and magnetic field due to acceleration of the charge body propagates in the free space as electromagnetic wave. And this wave is nothing but what? Even you can say light wave, because light wave itself is electromagnetic wave. It will depend on that with what frequency or how rapidly you accelerate the charge particle. If you accelerate the charge particle rapidly, then it will achieve the frequency of visible light and so on. But there is a limitation to our mechanical system that we cannot accelerate the charge particle beyond certain limits. So it's not possible to have a component of visible lights or frequency like that. But mechanism will remain same. If one is able to accelerate the charge particle with that much frequency, then that charge particle will radiate a light wave. So conclusion is that change in electric and magnetic field don't happen immediately. It takes time for changes in electromagnetic field, electric field and magnetic field to propagate through the space. And the speed of changing electric and magnetic field is responsible for the speed with which the wave can propagate in the space. So we can say that the speed of light or speed of electromagnetic wave will depend upon the speed with which electric and magnetic field present in the light wave changes. Now you can look over here. Let us check out a single charge particle in free space. And first of all, we keep the single charge particle at rest. Then there will be electric field only associated with this single charge particle, which is stationary. You see, this white line gives you electric field line that is emanating from the point charge or source charge. As charge itself is not right now at rest, so only electric field will be there associated with this source charge, and these field lines will extend up to infinity with the speed of light. Now, what will happen if one starts waving the charge particle in the free space? That means one starts accelerating the charge particle. In that situation, its electric field will go on changing, as well as magnetic field will go on changing because of its motion, and its motion is changing continuously, so magnetic field will go on changing, and as it is accelerating, so electric field also will go on changing, and change in electric field and magnetic field appear as a disturbance produced in time and space plane. And this disturbance propagates in the space in the form of electromagnetic wave. So let us check out how this disturbance produced. You see here, as soon as you drop a pebbles on a calm lake, you see that at the point of contact with the water, disturbance get created, and this disturbance is transmitted all around the point of disturbance or center where disturbance has already been created, and this disturbance transferred to the edge of the lake. Same thing happened here. When charge particle is stationary in the space, only it will have magnetic field and will be uniform magnetic field at a given position. But as soon as we change the position of source charge by waving the charge itself, then electric field changes its position with respect to an observer. That's why electric field go on changing. Now come to the point, as charge particle comes in motion, so magnetic field come into existence, and magnetic field is a velocity dependent field, therefore it will also go on changing, and hence due to change in electric and magnetic field, disturbance will propagate in the space with a speed with which charge particle is accelerating or electric and magnetic field is changing. As you know that in case of mechanical wave like sound wave, something materialistic property must be changing periodically, like air pressure or air density in the form of compression and rarefaction. And when this happens, we say that mechanical wave is generated. Now, what about the light wave or electromagnetic wave? There is no matter is present available in the space or vacuum. Still, these waves are able to propagate, and these are the waves. Electromagnetic wave is a type of wave in which there must be certain characteristics periodically changing. And what characteristics continuously changing or periodically changing in electromagnetic wave? Here we see that electric field and magnetic field associated with the charge particle is periodically changing. As a result, electromagnetic waves generated and propagate in the space. Look at here we move the position of the charge particle with the help of mouse we are having in my hand. So you see here disturbance just get created, and a red ball you see here is nothing but what a charge body. You can see the source charge. So when we change the position of this charge particle in a space, you see that electric field and magnetic field continuously changing, and change in electric field and magnetic field appears as electromagnetic wave and is transmitted into the space with the speed with which electric field and magnetic field is changing. Therefore, if you increase your speed of waving the charge particle, the change in magnetic field and electric field also increases rapidly, and so frequency of electromagnetic wave increases. Therefore, you can say that electromagnetic wave will have a frequency range up to infinity starting from zero, because we don't have limitation to oscillate and accelerate the charge particle. So with it depends on how rapidly you change the electric and magnetic field associated with the charge. So we have seen this here, that light is electromagnetic wave. Now come to the point. As we see, we all are familiar with the speed of light and classical equation of electromagnetic wave, or simply wave. This is equal to a speed of wave is equal to product of frequency and wavelengths. So we see here c is the speed of light in vacuum, and this is the ultimate speed of the universe. Nothing can move with this speed. And f is the frequency of electromagnetic wave and wavelengths. Lambda is the frequency of lambda is the wavelength of electromagnetic wave. As we see here, the expression, all the components of electromagnetic wave will move with the same speed c in vacuum, although they are having different frequency and different wavelengths. How it is so? Because frequency and wavelengths are inversely proportional, inversely related to each other, therefore their product remain constant. So you can say that speed of all component of electromagnetic spectrum will remain same. Now our main question is there, that why light get bent from its actual path while making a transition from one medium to another medium. So that question is now being answered here. As we know that a speed of light in vacuum is the fastest possible speed. This is the ultimate speed of the universe. Nothing can move beyond this speed. And no object has ever been recorded moving faster than that of the light. So as object approaches the speed of light, their time get dilated and length get contracted for that object which is moving a comparative speed compared to that of the speed of light. So time dilate means the time gets slow for that object which is moving faster in comparison to light, or which is moving or approaching the speed closer to that of the light. For that object, time will get dilated. That means time will be slower and space will get contracted. That this implies that as one starts moving or increasing a speed in order to approach the speed of light, for them time becomes slower and slower, and space contracted smaller and smaller. That is, x coordinates and y coordinates and z coordinates go on contracting and contracting, ultimately get converted into a point. That means dimension of reference frame will get vanished into a point in that situation. So come to the point here, a light wave moves slower in a denser media, material media. So far we have discussed right now for the vacuum. Now we come to the material media. Light wave moves slower in a denser media. Why? Because light induces electric polarization in a material medium. We all are familiar with the polarization in electrostatic chapter. So what is polarization? You know well that when a dielectric substance or conducting substance, when placed in a uniform electric field, the mobile electron gets shifted at one side in opposite direction of electric field, causing the other side being positive by equal amount, and opposite side becomes negative by equal amounts. And we know that separation of equal and opposite charge causes electric dipole moment induced in that matter. And because of this induced dipole moment, there will be an additional electric field inside the material body, which will either oppose the source field or will add up to the source field, depending on nature of material. In case of dielectric material, electric field inside the dielectric material get decreased. On the other hand, electric field in case of conducting material get increased or not increased, even then get decreased, because in conducting material, dielectric constant is infinite. Therefore, electric field becomes zero inside the conducting material. So you are, all of you are being familiar. All of you are familiar with that concept that electric field inside a conducting material is zero in electrostatic state. Why? Because dielectric constant of conducting material is infinite. That's why electric field inside the conducting material is zero. Although there is finite electric field outside the material. But in case of dielectric material, electric field will be a little bit lesser in comparison to that of the source field. And the phenomenon of inducing a net dipole moment in the bulk of material when placed in electric field is called electric polarization. And electric polarization induces an additional electric field which opposes the source field. So polarized matter radiates new kinds of wave because electric field present in the source light keeps on changing. Therefore, this electric field, when enters into the material medium, also keeps on changing. As a result, an induced electric field get developed there inside the material medium that interfere with the original field of the light wave, and that's why form a delayed wave. That means slow down the speed of wave inside the material medium. As because of that, the light wave bends either towards the normal or away from the normal while passing from one medium to another medium. This is the basic reason that electric field present in the light induces a polarized field inside the bulk material, inside the bulk of the material through which it passes. As a result, the material radiates a new kinds of radiation that interfere with the original light, and hence the resultant wave get delayed, because original light wave and light wave that is radiated inside the material due to polarization interfere together, and if they interfere in the same phase, then there will be no change in the speed, and hence light will pass through the material medium without deviation. And when there is opposite phase between the source light and polarized light, or light radiated due to polarization in the material, then there will be the interference, and even you can say destructive interference, and that's why light will have slower speed in that material medium in that case. This is the basic cause. When light wave enters in a medium with an angle of incidence with 0°, that is, it enters along the normals to the interface, there is no deviation. You can say that in that case, the phase difference between the original light waves and the light wave radiated by the material medium, that's why it passes without any deviation. And here you can see that in vacuum, light wave has this much speed. As light make a transition from vacuum to air, its speed decreases. And when it makes a transition from vacuum to water, its speed decreases. And when it make a transition from vacuum to diamond, its speed decreases to this much, indicating that various material medium produces a matter wave or matter light wave, which is produced due to polarization in different phase. That is, phase difference may be different from the source in comparison to the various medium, and because of that phase difference, a speed of light changes in various medium, and as a result, wavelength also changes. But while light moving from one medium to another medium, its frequency remains same. So this is the basic fact about the question that I wanted to answer, and this is the authentic answer, because when light enters in a medium, there are two kinds of light waves. One due to the original light wave that is coming from the outside, and another is the light wave that is produced in the material medium because of polarization in that matter. And polarization arises because of periodic variation of electric field present in the source light, which is coming from the outside, that you can say that incident light. So now, as we look into the matter, in the bulk of matter, there are two kinds of light. One is source light, original light, and another is light produced because of polarization in the matter. And these two lights might be in the same phase or in the different phase, depending on the angle of incidence or angle of original light with respect to normal. If angle is 0, then a phase difference between the original light wave and light wave produced in a matter due to polarization is 0. So there is no deviation in that case. So thank you. That's all about I want to show you. And the next video I will show you new questions that is unanswered by now, at least among us. So next day we will discuss about the new questions, and even you may ask me questions and put your questions on WhatsApp group. Thank you.